35th New Shepard launch, 15th payload launch over. I'm Tabitha Lipkin.
And I'm Claire Luce.
And this is NS-35.
The human.
Good morning, everyone. Once again, I'm Tabitha Lipkin, and joining me is Claire Luce. Claire, please tell our viewers all about yourself.
Hi, everyone. I'm so excited to be here. Here at Blue Origin, I am a propulsion engineer for the BE-3PM engine, which is New Shepard's engine. More specifically, I work with an amazing team responsible for the engine on launch day. So typically, I'm sitting in the engineering back room supporting our booster controllers, but today I'm here with you all.
And we are so grateful to have you here with us. Now, as I mentioned, this is our 35th mission overall, 15th dedicated payload flight, and 7th New Shepard mission this year. Now, our previous attempts were scrubbed after the team encountered an issue related to the booster's avionics. The team has been working diligently, and we're ready to fly today.
And we are flying more than 40 payloads today. After today's flight, we will have flown more than 200 scientific and research payloads to space.
Our NS-35 mission will provide over 3 minutes of that clean microgravity for experiments from a range of organizations, including Johns Hopkins Applied Physics Laboratory, Oklahoma State University, University of Florida, Carthage College, University of Central Florida, Teledyne, Space Lab Technologies, and Teachers in Space, among others.
And 24 payloads are part of the NASA TechRise Student Challenge, which empowers teams of 6th to 12th graders to design, build, and launch experiments on NASA-supported test flights.
Now, this flight utilizes our dedicated payload capsule, RSS H.G.WELLS, and newest booster, New Shepard booster, the same vehicle combination, by the way, that flew on NS-29 in February and successfully demonstrated lunar gravity simulation inside the capsule.
And today is a payload launch. But if you're keeping track, New Shepard has flown 75 humans above the Kármán line. That's more than 10% of all the people above the Kármán line.
Now let's dive in a little deeper on some of the manifest highlights on today's payload flight of NS-35. Now first up, we have A.R.E.S. Ecoatoms. The A.R.E.S. payload is the first of its kind, featuring a unique structure designed for chemical coatings and microgravity.
Have the Biological Imaging in Support of Suborbital Science, or BISS, from the University of Florida. Principal investigators Rob Furl, who flew on NS-26, and Annalisa Paul are adapting ISS-based technology for suborbital use with their experiment BISS.
We also have propellant refueling and on-orbit transfer operations, aka PROTO, and Microgravity Ullage Detection, aka MUD. Now, Carthage College Space Sciences program PROTO experiment is collaborating with NASA Johnson Space Center to test new alternatives to measure spacecraft propellant levels in microgravity. MUD is a non-invasive method to locate the liquid vapor interface in spacecraft fuel tanks during microgravity.
And next we want to talk about EDR Fuel Cell from Teledyne in collaboration with NASA Glenn's Research Center. Teledyne has spent over a decade developing a fuel cell technology that generates electricity and water from hydrogen and oxygen supplies aboard space vehicles. This experiment will test the system across all mission phases and serve as a foundational step towards scaling up power and water production to support long-term lunar and Martian habitation.
And finally, we have to talk about Teachers in Space, or TIS. We have TIS-3 and TIS-4, and Teachers in Space provides training and flight opportunities for classroom spaceflight experiments designed by teachers and their students. This payload is flying experiments from New Mexico, New York, and Maine, focused on radiation detection and protection, as well as sound level detection and environmental data collection. All right, right now we're about T-minus 9.5 minutes. Let's toss it over to the rocket as New Shepard is on the pad awaiting the launch of NS-35 across the Kármán line. Just a beautiful day out in West Texas, and I am getting word that we are go for terminal count and launch. But right now, we want to take a moment to focus on the NASA TechRise Student Challenge, which is a part of today's payload flight. Now, as we mentioned, the NASA TechRise Student Challenge provides a hands-on opportunity for students in grades 6 through 12 at U.S. schools to gain critical skills in engineering, computing, electronics, and more that will be required for America's technical workforce.
And the 24 student payloads include experiments on space farming, medical solutions, and the behavior of liquids in microgravity. NASA's Flight Opportunities Program manages TechRise, which is administered by future engineers.
And for today's webcast, we actually have some questions from our TechRise students that we are so excited to help answer. So we're going to start with this first question, which is, how do you transport the rocket and get it into position for launch? Claire, you want to answer this?
Sure. Well, for New Shepard, we use something called the Transporter Erector. It's a special grounds transport tool that weighs over 110 metric tons. It's able to be pulled with a trucking rig and contains a built-in hydraulic system and attachment points that serve to change the orientation of the New Shepard vehicle from the horizontal to vertical position, or vice versa.
All right, our next question is, what plans do you have for future bigger rockets?
Well, we have big plans. We have a bigger rocket called New Glenn, our heavy lift launch vehicle, which is named after John Glenn, the first American to orbit Earth. New Glenn flew for the first time on January 16th this year and safely reached orbit. Fun fact, before we flew New Glenn, we flew all the same avionics on an uncrewed New Shepard flight just like this one.
All right, our third question is, how much fuel is used per minute or per second?
Well, this is my favorite question because I'm biased towards the engine. But the B3PM engine uses over 120 gallons per second of propellant. That's both liquid oxygen and liquid hydrogen. And fun fact, B3PM could drain a small pool of 10,000 gallons in about a minute and a half.
That is incredible. All right, our final question here is, what is the maximum weight a rocket can carry?
Well, at takeoff, the rocket also has to carry itself and provide a little more thrust than what it weighs. So knowing the thrust of the rocket at takeoff is a good way to approximate the maximum weight that a rocket can carry. For the suborbital New Shepard, we typically carry over 1,000 kilograms inside the crew capsule, which is about 2,000 pounds. However, New Glenn can carry about 99,000 pounds to low Earth orbit.
Absolutely incredible. All great questions from our TechRise students. Thank you so much for taking the time to ask. The future is looking super bright for the next generation. And speaking of a bright future, we have to talk about our nonprofit Club for the Future, which is sending postcards to space and back on New Shepard from space enthusiasts and partners, including Denise De La Rue and her partners of Fundication Emmanuel and Fundication Azteca, as well as North Taps Middle School.
And anyone can do this. And of course, there's our digital postcard drawing tool that anyone can use. To send your own art to space, just go to draw.clubforfuture.org.
And again, that's draw.clubforfuture.org. And Club has a mission to inspire and mobilize future generations to pursue careers in STEAM. That's science, technology, engineering, arts, and math, all for the benefit of Earth.
And Club for the Future has an exciting new lesson called Launching into Physics, Analyzing Rocket Performance Through Data Graphing.
Now, students can actually watch a New Shepard launch, then dive into real data to plot its trajectory, as well as calculate acceleration and force, applying theoretical concepts to a real-world event. By the way, Club has engaged nearly 95 million people globally through initiatives including Postcards to Space, the standard-aligned lessons like the one we just mentioned to help our teachers, and of course, also our ambassador program. And since we have so many future leaders of STEAM careers watching today, let's explain the flight profile of New Shepard. It has a flight path that spans about 11 minutes total. So here's the chart on your screen showing how the flight progresses from launch to landing. So Claire, let's go through it.
Sure. Well, it starts at T-0 with the B-3PM engine propelling New Shepard off the launch pad in West Texas. The engine drives New Shepard to space, passing max Q, and at 2.5 minutes, we'll experience MECO, or main engine cutoff.
Now, at that point, the crew capsule separates from the booster, continuing its parabolic flight past the Kármán line and experiencing several minutes of that clean microgravity.
And while the payloads are in the crew capsule conducting experiments, the booster descends faster due to its more aerodynamic shape.
It deploys ring fins and drag brakes upon re-entry, and the BE-3PM engine relights for an autonomous landing on the pad, where the ground team begins readying it for its next flight.
Meanwhile, the capsule starts re-entry at 3.5 minutes after separation. Parachutes deploy for a smooth landing, and on the ground, it is greeted by our capsule recovery team and the eagerly awaiting payload customers.
Now, every New Shepard flight has essentially the same profile, but every now and then we do have a slight variation. But we can't wait to see the results from the experiments on today's payload flight. Right now, we are about T-minus just under 3 minutes as New Shepard awaits liftoff, and soon we're going to be going through a series of bit checks. Now, for our viewers who don't know, Claire, we've got a lot of students watching. What is a bit check?
Yeah, so these bit checks, or BIT really stands for built-in test, and we're just checking out all the systems on the vehicle before it actually launches.
That's right. So right now we're going to toss it over to the rocket. We've got that beautiful drone shot there of New Shepard on the pad, and shortly you'll be hearing little pieces of those bit checks that start right around the 2-minute mark. Let's go ahead and listen in. You can really hear New Shepard coming alive. Now, if you're just joining us, we are about T-minus a minute and a half. NS-35 is awaiting launch to cross the Kármán line with our second payload flight this year. Now, some of the bit checks that we are going through at this moment in time are AFIN checks, which help steer the vehicle on ascent and descent. The bridge has retracted. Also, there's something that viewers won't see, and that's the engine nozzle.
Yeah, so we actually gimbal the engine, and we do that check as well. And this helps maneuver the rocket and ensure a free range of motion on ascent and descent.
We're also, of course, keeping an eye on the pressure and temperature in the propellant tanks. Both need to stay in the green zone. Beautiful shot there with the sunrise over West Texas and New Shepard on the launch pad. At about T-minus 20 seconds here, It is time to go, so we're going to hand it off to Mission Control and launch this rocket. Go, New Shepard, go.
10, 9, 8, 7, 6, 5, 4. Command engine start. 2, 1. Ignition. Now liftoff.
And New Shepard has cleared the tower. If you're following along from home, you can note the speed and altitude graphics on your screen to the left. And as the capsule and the booster separate, you'll also be able to see those graphics split and follow their ascent and descent as well.
And right now, the engine is at 100% power level.
A beautiful shot there of the BE-3.
Begin throttle down for Q limiting. Engine response nominal.
And here we are approaching our Q bucket.
What is that, for our viewers who don't know?
It's where
Max
there's...
Q, maximum dynamic pressure.
Oh, we have the max aerodynamic stress on the vehicle, and so we're actually going to power down the engine as we go through that bucket.
Excellent.
Mach 1, vehicle is supersonic. Engine maintaining full throttle. Chamber pressure is nominal.
We're about a minute and a half, just passing 60,000 feet.
I love shots like this where you can just see the glow of the engine.
Yeah, the BE-3 shining bright. A great shot from our long-range camera. Over 100,000 feet now. And we've also got a camera there on the booster looking back down on West Texas.
Begin throttle down. Stand by MECO.
For our viewers who are just joining us and don't know, MECO is our main engine cutoff.
MECO confirmed.
And there you have it.
Standby separation. Separation confirmed.
And as I mentioned, if you look to the left-hand side of your screen, you'll notice that the telemetry has split, so you'll be able to follow the capsule and the booster separately. They reach apogee at right about the same time.
Capsule body rates look good.
You'll also notice on your screen, we've reached 0G. I know there are so many students and teachers watching today. We say hello to you, and we are also excited to learn more about your experiments and the results of those experiments. When,
Capsule has passed the Kármán line.
And there you have it. The capsule has passed the Kármán line. And yeah, we can't wait to learn more once NS-35 returns back to West Texas. I always think it's so cool to have that split screen where you can see Texas from the booster, and we've got that long-range camera that I know it's kind of hard to see, but we do have the booster and the capsule there.
Capsule apogee at 345,000 feet.
Yeah, soon on the image on the right, we'll be able to see, oh, you can kind of see it. You can see two little dots. That is the capsule and the booster.
They've reached apogee, they've crossed the Kármán line, and now they are making their way back down to West Texas. And since we do have so many students watching today, Claire, do you want to kind of explain
4
why
minutes, 35.
the booster will land first?
Yeah, so the booster is going to land about 2 miles north of the launch pad, and it is more aerodynamic, so it is going to go through the air a lot faster than the capsule. Therefore, it's going to land before the crew capsule lands.
That's right. The crew capsule, as you notice, is more of a teardrop shape.
Booster descent nominal through 300,000 feet.
And we are watching the booster and the capsule from our long-range cameras out in West
Capsule
Texas.
body rates look good.
Just over 5 minutes into NS-35.
Booster descent nominal.
The booster coming in under 200,000 feet. An autonomous landing is what you'll see, again, as Claire mentioned, about 2 miles from our launch pad.
Capsule has reached atmospheric pierce point. Confirm booster forward fin deploys.
So those forward fins are some of our aerodynamic surfaces that help us fly and return back to the landing pad.
Here comes the booster. Just past 6.5 minutes into flight. Great shot there.
Booster drag brakes deployed.
And now we're coming up to my favorite part, is when we will actually relight the engine.
And the
Approaching
booster
engine
lands.
restart.
Let's see it.
Engine restart. Landing lights deployed. Booster touchdown. Welcome home, New Shepard booster.
Welcome home, New Shepard booster. Yes, beautiful touchdown and
Starting
great
booster auto
shots
syncing.
from our camera operators. There you can see the capsule, as we mentioned. It takes the capsule a little longer because of its teardrop shape to return back to the West Texas desert.
Capsule descent nominal. Standby capsule drogues. Capsule drogues deployed.
And there go the drogues. Shortly,
Standby mains.
you will see those main parachutes pull out as well.
Mains deployed.
And you may notice that our parachutes do look a little different from our last few missions. That's because we're flying our upgraded system today as a verification step prior to flying it on future astronaut missions.
Capsule landing zone is within expected range limits.
Yes, we have all 3 parachutes that have reefed out. Now, while the parachutes are essential for providing a gentle touchdown for the capsule, New Shepard also has a retro thrust system at the base of the capsule, which will make the final touchdown even smoother. The system fires just moments before touchdown to slow the capsule down to just 1 mile per hour. It kicks up a lot of that West Texas dust, but rest assured the
Capsule
payloads
descent
today
past 1,000 feet,
will have a
TDS
nice
enabled.
soft touchdown. The capsule crossing the sunrise. What a beautiful shot there. We are 10 minutes into NS-35.
Approaching retro thrust fire.
Moments from the capsule touchdown.
Capsule touchdown.
There you have it. The capsule has touched down. Always incredible to see our new Shepard crew capsule.
Start. Thanks
Now,
for flying
our crew
with this
recovery
news
team is currently driving out to meet the capsule, and they're going to safe the vehicle and get it ready in order to get those payloads out and to be able to get our teachers and our students with all the information that they need from the experiments that flew today. So I know that is such an exciting moment right now.